All right, so here we've got a linear over a square root of a quadratic. We'll try this with a completing the square on the bottom, right? And so in order to complete this square, I'm going to add 4 and subtract 4. I'll push the negative 3 out, change it to a positive 3, change the positive 4 to a negative 4, and change the x squared to a negative x squared here so I can factor out my negative. Completed this square, x squared minus 4x plus 4 gives me this, okay? And then the negative 4 plus 3 gives me the negative 1, okay? I've got my negative still out front. Now I factor my negative back in, and I get x minus 2 squared over here because it's negative, so I push it over to this side, and then my negative gets factored back in here to give me my positive 1. Okay. Now I've got my numerator just stayed the same. Now I'm going to push my numerator out into 2 separate ones. So I'll leave my 2x here, and I'll push my negative 3 out to here and expand my denominator into 2 different integrals. Okay. Now this integral is a pretty easy one. It's just a simple sine inverse substitution there. This one, because it's got an x in the top, it's a little bit different. So I'm just going to let x minus 2 equal sine theta, which is this guy. And then dx, therefore, equals cosine theta d theta, derivative of all of this stuff. I made a little triangle here to help us a little bit later on, because sine theta is the opposite. So here's theta, it's the opposite over the hypotenuse, and so that's 1. So there's a 1 here. And that gives us this side using the Pythagorean theorem. You can solve for this side over here. Now, that's all being, I took this integral and I rewrote it here. So now I'm going to make a bunch of substitutions. If I pass this negative 2 over, I get x equals sine plus 2. So that x gets replaced by a sine plus 2. By the way, that 2 got moved out here. My dx happens to be cosine theta d theta, so this dx, I changed it to cosine theta d theta. And then here, this is all, I'm changing my x minus 2 into a sine theta. And since it's squared, it's a sine squared theta. Now I got trig identity, 1 minus sine squared is cosine, and then if it's cosine squared, and if I square root it, therefore it's the square root of a cosine squared is just a regular cosine. That cosine and that cosine cancel, leaving me sine theta plus 2 d theta. I'll put my 2 back in here. And so basically I'm going to take sine theta plus 2, right? And that 2 became the 4 because this 2 factors or can be multiplied back in. And now, taking these derivatives here, integrals, the integral of sine is negative cosine. The integral of 4 is 4 theta. Going back up to that triangle, cosine theta is the adjacent to theta divided by the hypotenuse. So it's just the adjacent to theta right there. And then the theta itself is the sine inverse of x minus 2. Did I do that right? Yes, x minus 2, because it's the sine inverse. It's the opposite over the hypotenuse, the sine of theta. Basically, over here, you can solve for that sine inverse. You're solving for theta, and so therefore, theta is the sine inverse of x minus 2. This is up here. This was where was that? Oh, that's from up here. So I brought this guy way down to here, and there it is. So now I've got a 4 sine inverse of x minus 2 minus 3 sine inverse of x minus 2. That one was from way up there, and giving me 4 minus 3 is 1. And this is going to turn out to be our final integral. I've done this in a different way as well. I'll put a link to that one in the description.